Hi, I'm Laura. We had completed structure of Java program in last class. We have Mr. Joy to cover other topics related to overview of Java language.
Hi Laura. Yes, we will cover other topics of overview of Java language today. So, let's start. We will cover these topics: Java tokens, Java statements, implementing a Java program, Java virtual machine, command line arguments, and programming style. I hope you will get to know some more basics of Java language after complete these topics.
Thanks Mr. Joy, for covering up these topics.
So, let's start from Java tokens. Java tokens. A Java program is basically a collection of classes. A class is defined by a set of declaration statements and methods containing executable statements, as displayed in the figure. Most statements contain expressions, which describe the actions carried out on data. Smallest individual units in a program are known as tokens. The compiler recognizes them for building up expressions and statements. In simple terms, a Java program is a collection of tokens, comments, and white spaces. Java language includes 5 types of tokens. They are reserved keywords, identifiers, literals, operators, and separators. Java character set. The smallest units of Java language are the characters used to write Java tokens. These characters are defined by the Unicode character set, an emerging standard that tries to create characters for a large number of scripts worldwide. The Unicode is a 16-bit character coding system and currently supports more than 34,000 defined characters derived from 24 languages from America, Europe, Middle East, Africa, and Asia, including India. However, most of us use only the basic ASCII characters, which include letters, digits, and punctuation marks, used in normal English. Keywords. Keywords are an essential part of a language definition. They implement specific features of the language. Java language has reserved 50 words as keywords. This table lists these keywords. These keywords, combined with operators and separators according to a syntax, form definition of the Java language. Understanding the meanings of all these words is important for Java programmers. Since keywords have specific meaning in Java, we cannot use them as names for variables, classes, methods, and so on. All keywords are to be written in lowercase letters. Since Java is case-sensitive, one can use these words as identifiers by changing one or more letters to uppercase. However, it is a bad practice and should be avoided. Identifiers. Identifiers are programmer design tokens. They are used for naming classes, methods, variables, objects, labels, packages and interfaces in a program. Java identifiers follow the following rules. 1. They can have alphabets, digits, and the underscore and $sign characters. 2. They must not begin with a digit. 3. Uppercase and lowercase letters are distinct. 4. They can be of any length. Identifier must be meaningful, short enough to be quickly and easily typed and long enough to be descriptive and easily read. Java developers have followed some naming conventions. Names of all public methods and instance variables start with a leading lowercase letter. Examples: average, sum. When more than one words are used in a name, the second and subsequent words are marked with the leading uppercase letters. Examples: day temperature, first day of month, total marks. All private and local variables use only lowercase letters combined with underscores. Examples: length, batch underscore strength. All classes and interfaces start with a leading uppercase letter, and each subsequent word with a leading uppercase letter. Examples: student, hello Java, vehicle, motorcycle. Variables that represent constant values use all uppercase letters and underscores between words. Examples: total, f_max, principal_amount. They are like symbolic constants in C. It should be remembered that all these are conventions and not rules. We may follow our own conventions as long as we do not break the basic rules of naming identifiers. Literals. Literals in Java are a sequence of characters, digits, letters, and other characters that represent constant values to be stored in variables. Java language specifies 5 major types of literals. They are integer literals, floating point literals, character literals, string literals, and Boolean literals. Each of them has a type associated with it. The type describes how the values behave and how they are stored. Operators. An operator is a symbol that takes one or more arguments and operates on them to produce a result. Separators. Separators are symbols used to indicate where groups of code are divided and arranged. They basically define the shape and function of our code. Please find the list separators and their functions. Parentheses, used to enclose parameters in method definition and invocation, also used for defining precedence in expressions, containing expressions for flow control, and surrounding cast types. Braces, used to contain the values of automatically initialized arrays and to define a block of code for classes, methods, and local scopes. Brackets, used to declare array types and for dereferencing array values. Semicolon, used to separate statements. Comma, used to separate consecutive identifiers in a variable declaration, also used to chain statements together inside a for statement. Period, used to separate package names from subpackages and classes, also used to separate a variable or method from a reference variable. I hope you got to know the Java tokens.
Yes, Joy. I understood the Java tokens and its rules.
Good. Then let's move to Java statements. Java statements. The statements in Java are like sentences in natural languages. A statement is an executable combination of tokens ending with a semicolon mark. Statements are usually executed in sequence in the order in which they appear. However, it is possible to control the flow of execution, if necessary, using special statements. Java implements several types of statements as described in table. They are considered in depth as and when they are encountered. Empty statement, these do nothing and are used during program development as a placeholder. Labeled statement, any statement may begin with a label. Such labels must not be keywords, already declared local variables or previously used labels in this module. Labels in Java are used as the arguments of jump statements, which are described later in this list. Expression statement, most statements are expression statements. Java has 7 types of expression statements: assignment, pre-increment, pre-decrement, post-increment, post-decrement, method call and allocation expression. Selection statement, these select one of several control flows. There are 3 types of selection statements in Java: if else, and switch. Iteration statement, these specify how and when looping will take place. There are 3 types of iteration statements: while, do and for. Jump statement. Jump statements pass control to the beginning or end of the current block, or to a labeled statement. Such labels must be in the same block, and continue labels must be on an iteration statement. The 4 types of jump statement are break, continue, return and throw. Synchronization statement. These are used for handling issues with multithreading. Guarding statement. Guarding statements are used for safe handling of code that may cause exceptions, such as division by 0. These statements use the keywords try, catch, and finally. Please find this figure to understand the classification of Java statements. Laura, I hope you got to know about Java statements.
Yes, Joy, I understood the Java statements and its classification.
Good, Laura. Then let's move to implementation of Java program. Implementing a Java program. Implementation of a Java application program involves a series of steps. They include creating the program, compiling the program, and running the program. Remember that, before we begin creating the program, the Java Development Kit, JDK, must be properly installed on our system. Creating the program. We can create a program using any text editor. Please find this figure to understand the implementation of a Java program. Step 1. Source code. Let's take an example of source code, for example test.java file, which contains a Java program with main method. Step 2. Compiling the program. To compile the program, we must run the Java compiler, javac, with the name of the source file on the command line as shown in the screen, javac test.java. If everything is okay, the javac compiler creates a file called test.class containing the bytecodes of the program. Note that the compiler automatically names the bytecode file as classname.class. Step 3. We need to use the Java interpreter to run a standalone program. At the command prompt, type Java test. Now, the interpreter looks for the main method in the program and begins execution from there. When executed, our program displays the output. Note that we simply type test at the command line and not test.class or test.java. The compiler converts the source code files into bytecode files. These codes are machine independent and therefore can be run on any machine. That is, a program compiled on an IBM machine will run on a Macintosh machine. Java interpreter reads the bytecode files and translates them into machine code for the specific machine on which the Java program is running. The interpreter is therefore specially written for each type of machine. This figure illustrates this concept. Java Virtual Machine. All language compilers translate source code into machine code for a specific computer. Java compiler also does the same thing. Then, how does Java achieve architecture neutrality? The answer is that the Java compiler produces an intermediate code known as bytecode for a machine that does not exist. This machine is called the Java Virtual Machine and it exists only inside the computer memory. It is a simulated computer within the computer and does all major functions of a real computer. The figure illustrates the process of compiling a Java program into bytecode, which is also referred to as virtual machine code. The virtual machine code is not machine-specific. The machine-specific code, known as machine code, is generated by the Java interpreter by acting as an intermediary between the virtual machine and the real machine as shown in figure. Remember that the interpreter is different for different machines. Layers of interactions for Java program. This figure illustrates how Java works on a typical computer. The Java Object Framework, Java API, acts as the intermediary between the user programs and the virtual machine, which in turn acts as the intermediary between the operating system and the Java Object Framework. Command line arguments. There may be occasions when we may like our program to act in a particular way depending on the input provided at the time of execution. This is achieved in Java programs by using what are known as command line arguments. Command line arguments are parameters that are supplied to the application program at the time of invoking it for execution. Please find one example to pass arguments using command line. Programming style. Java is a free-form language. We need not have to indent any lines to make the program work properly. Java's system does not care where on the line we begin typing. While this may be a license for bad programming, we should try to use this fact to our advantage for producing readable programs. Although several alternate styles are possible, we should select one and try to use it with total consistency. Please find this example with different style. Laura, I hope you got to know about Java language. We covered almost all topics related to overview of Java.
Yes, Joy, it was really good, easy to understand, and we covered almost all topics related to this.
Great. Really, it's an interesting coding language. We can do complex coding in simple way.
Yes, Joy. You are right. Thank you for covering all these topics for overview of Java language.